This is Pre-Calculus 12, Chapter 5.8. We're going to be looking at solving problems with log and exponential functions. First, we'll look at more financial problems. This is the future value formula. So FV equals the payment times 1 plus the interest rate to the power of n minus 1 over I. And I is the interest rate per compounding period. So really, this is divided by C and divided by C. And the number of payments is the number of years times the number of compoundings. Okay, this is a simplified version because compounding usually doesn't match the number of payments. This is a savings formula, and it's different than the one-time investment formula. What happens is you're making regular contributions to your savings plan. So it's called future value because you start off with 0 as your present value, and you don't know what the future value of your investment is going to be, and that's what this calculation is for. We also have a present value formula. So we borrow money, we make payments, and we know that the future value is going to end up being 0 because you pay all the money back, and that's why it's called a present value problem. So it's a loans formula. So let's look at a problem. Determine how many months are required to save $1.3 million with monthly deposits of $1,000 at 5% interest compounded monthly. So we have future value equals monthly payments 1 plus the interest rate, number of payments, minus 1. Substitute our known values. This is 1.3 million. And our payments are $1,000. And 1 plus the interest rate per compounding period, 0.05 divided by monthly compounding is 12. And n is just the number of payments. And we divide this by 0.05 over 12. Now we just do some algebra. It's best to do all the algebra at once before we plug it into our calculator. That way we avoid any rounding errors. This is in the denominator, so we need to multiply it into the other side. So 0.05 divided by 12. This is in the numerator. It goes into the denominator on the other side because we're multiplying. And now we have 1 plus 0.05 divided by 12 to the power of n minus 1. We can do a little bit of simplification here. We can cancel out 3 zeros. Now we just add 1 to this side. 1 plus 0.05 divided by 12 equals 1 plus 0.05 divided by 12 to the power of n. We take the log of both sides. And we get n log. And now we can isolate n by dividing this side by log. And our answer is going to be in number of payments, not number of years. And we can go ahead and plug this in on a calculator. And we don't really need a graphing calculator for this. divided by log. And we have all the brackets that we need. There's one left, one right, a right, a right, a left, and a left. And that matches up. And we get 447.06. And we won't have 1,000,003 if we have 447 months. So we round up. And at 448 months, we will have the 1.3 million. And if we want to convert this to years, we have 37 years. 448 minus 37 times 12, and that means 4 months left over. And if you started at age 25, you would be age 62 to get your $1.3 million. Let's look at another problem. A couple wants to borrow $400,000 to buy an apartment. They can afford $2,600 a month with an interest rate of 3.5% compounded monthly. How long will it take to repay the mortgage? So this time we use the PV formula. And it's good to write this out. It'll help you memorize it over time. 1 plus I to the power of negative n all over I. Substitute our values. 400,000, 2,600, 1 minus bracket 1 plus 0.035 divided by 12 to the power of negative n over 0.035 divided by 12. Again, we want to do all our algebra before we plug it into our calculator. This is in the denominator. We need to move it into the numerator of this side. .035 divided by 12. This is in the numerator. We need to bring it in the denominator of this side. Let's cancel out some zeros so we don't have to keep writing them. Now we want this to go over to this side so it stays positive. So we'll bring this over to the other side. So we have 1 plus 0.035 divided by 12 to the power of negative n equals 1 minus 4,000 times 0.035. And we'll just move this 12 into the denominator. Now we take the log of both sides. Negative n log 1 plus 0.035 divided by 12 equals log 1 minus 4,000.035 over 26 times 12. Now we just divide both sides by negative log 1 plus 0.035 divided by 12, and we have our n. Put the negative sign in the numerator. And plug this into the calculator. Negative log. Log already has brackets, so we don't have to add extra brackets. divided by 26 divided by 12. Optionally, you could put divided by adding another set of brackets, 26 times 12, but I prefer to do divide twice. And we have 1, 2 right brackets, 1, 2 left brackets, so we're good. Now we can divide by log 1 plus 0.035 divided by 12. And we have matching brackets there. And we get 204.47 months. And again, if we do 204 months, we won't have paid off the loan. So we need to round up. 205 months. 205 divided by 12. This gives us 17 years. And we do 205 minus 17 times 12 to find out our remainder, and that's 1 month. Okay, so it just takes over 17 years to pay off this loan. So again, be careful of rounding. Normally we round up so that we reach the desired value, but if we happen to round down, then that won't happen. We won't get to our desired value. However, on many tests and homeworks, it asks you to round off, so just do as it says. But we know the right way to do it if we were doing this for real. Let's look at another problem. And this is a musical problem. There's 12 semitones and they have equal ratios. This means it's an exponential function. The notes are C, C sharp D, D sharp E, F, F sharp G, G sharp A sharp B. An octave always starts at C, ends in B. So each octave is double the frequency of the previous. D3, that's D in the third octave, is 146.8 hertz. Another note is played at 659.3 hertz. What is that second note? And the lowest note is C0. We call it the 0th note. This is not necessary. We can just use our specified value rather than the initial value. Or we can just make this our initial value. Anyways, we have 659.3. We have a starting value of 146.8. Our ratio is 2 because it's double the frequency for each octave. And we have our note number. And we have 12 semitones. So our K is 1 over 12. Okay, so 2 to the power of n over 12 equals 659.3 divided by 146.8. We take the log of both sides, n divided by 12, log 2 equals log 659.3 divided by 146.8. Again, we want to keep doing the algebra all the way till the n is by itself, and then we can use the calculator. So log 2 is in the numerator, we put it in the denominator, and the 12 is in the denominator, so we move it into the numerator. All divided by log 2. And plugging this in, and divided by log 2. And we get 26 point something. However, this time we actually want to write an integer, because if there's a decimal value, then the frequency isn't an equal ratio. Have exactly 26 semitones. And if we have a decimal value, it means that we're actually off key. Now we need to take the 26 semitones. We divide this by 12 semitones per octave. And we get 2 octaves. 24 is 2 octaves, and we get 2 semitones remaining. So we have to count. D3, we add plus 2 octaves. This means we go to D5. Now we need to add 2 more semitones. So we count 1, 2, D5 plus 2 semitones gives us E5. And that's our answer. And we have a few other problem types to look at. Earthquakes. We calculate the magnitude by taking a log of the intensity over standard earthquake. This is always left as S. We don't have a numeric value for this. And if we want to do the inverse, I is equal to 10 to the power of the magnitude times S. And this is intensity and standard earthquake. And S just represents the minimum level of intensity that's measurable. Sound levels. This is measured in decibels. Again, that's a tenth of a bell. And this formula is 10 log the intensity divided by minimum sound level. So this is the minimum level before it can be recorded. And the inverse operation is we have 10 to the power of the decibels divided by 10 times the minimum sound level. Again, I naught, this is pronounced I naught, or you can say I0. It's left as I0, there's no value for it. And finally, alkalinity, pH, is negative log the hydrogen concentration. And if you want the inverse formula, the hydrogen concentration is 10 to the power of minus pH. Okay, let's look at some problems. An earthquake in California had a magnitude of 8, and an earthquake in Japan had a magnitude 6.5. How does the intensities compare? So we always compare the larger magnitude divided by the smaller magnitude. So MC for California equals log IC over S. That gives us 8 equals log IC over S. Now we exponentiate both sides with a base of 10. 10 to the power of 8 equals IC over S. So IC equals 10 to the power of 8 S. And it would have been simpler if we just used this formula, but I wanted to show you how we do the full calculation. So ij, we'll just use the formula, is 10 to the power of 6.5 s. Now we can do the comparison. IC divided by ij equals 10 to the power of 8 s, 10 to the power of 6.5 s. We can cancel out the s's. And we need to do 10 to the power of 8 minus 6.5. This is dividing powers, so we subtract exponents. 10 to the power of 1.5, and that is approximately 31.6 times the intensity. Okay, what is the intensity of a jackhammer at 110 decibels? Again, we can use the regular formula. L equals 10 log I over I naught. Substitute. 110 equals 10 log I over I naught. Divide both sides by 10. 11 equals log I over I naught. And finally, exponentiate both sides with base 10. 10 to the power of 11 equals I over I naught. And I equals 10 to the power of 11 I naught. Okay, what if we added a question that said, what if another jackhammer has half the intensity? What is the decibels? So we have I equals 10 to the power of 11 divided by 2 I naught. Then we say L equals 10 log 10 to the power of 11 divided by 2 I naught over I naught. These cancel out. And we can plug this in our calculator. 10 log 10 to the power of 11 divided by 2. And that gives us 106.99. 106.99 decibels. Now, we know that decibels is a log measure. It's a log measure, and we're multiplying it by 10. If we want half the intensity, here's the shortcut. We take our 110 decibels. This is already a log value. This is 10 times the log value of half the intensity. So we're multiplying by half. That means we're adding logs. We do this on the calculator. Plus 10 times log 0.5, and we get the same answer. And we can round that off to 107 decibels. Okay, so you can try to remember this quick way if you like, or you can go through the long method. And one last example. Determine the hydrogen concentration of a solution that has a pH of 3.5. Okay, so pH equals minus log AH plus. So we have 3.5 equals negative log AH plus. We exponentiate both sides, but we want to move the negative sign over first. So 10 to the power of negative 3.5 equals, and the logs cancel out, AH plus, and we plug this into the calculator. 10 raised to the power of negative 3.5. And let's write this in scientific notation. 3.16 times 10 to the negative 4. If you didn't want to write it in scientific notation, we'd write 0.000. We eliminate one of the zeros when it's a negative, and that's our answer. Another way of doing it is moving the decimal place over 4, 1, 2, 3, 4. And that completes this lesson.